All right, solving exponential equations with common bases. So the key is to make the bases the same and then solve the exponents. So the bases are the same, so write down the exponent on one side and the other, and then solve it. So add 8 and divide. Know that there are no extraneous solutions. The exponent can be negative, 0, positive, so that's a great answer. Number 2, the bases are the same, so just write down the exponents. Combine like terms. So I'm going to subtract x. So 5 subtract 1 is 4. I'm going to subtract 6. So that negative 12 subtract 6 is negative 18. And then divide. So it's negative 18 over 4, or negative 9 over 2, or negative 4.5. All that's good. 3. First, combine the bases together. So when you're multiplying, you add. So when I add them together, p plus 2p is 3p, and negative 7 plus 1 is negative 6. On the right, we just have the one base. The bases are the same. So I take one exponent equal to the other exponent. Combine like terms, so subtract 3, so that's 5. Add 36, that's 30. Divide, and you get your answer. 5 goes into 36 times. Here, so when you multiply, you add the exponents, so it's k squared and negative k and 9. On the other side, again, add them. 2 plus 3 is 5k, and 5 and negative 4 is 1. When the bases are the same, just write down the exponents. Notice this is a quadratic, so we're going to make it equal to 0. So I'm going to subtract 5k. I'm also going to subtract 1. And then I'm going to factor. So the two numbers that help me factor that are negative 4 and negative 2. They multiply to 8 and add to negative 6. So the 0 of each factor is positive 4 and positive 2. Number 5. This one, we need to make the bases the same. So 16 can be written with a base of 4 squared, and there's 11 there. Make sure that they multiply what you put there. So we have 3w plus 7 is equal to 22. Subtract 7, and I get 15. Divide, and you get the answer 5. Again, the bases aren't the same. I cannot write 32 with a base of 8, so the common base here would actually be 2. So 2 to the exponent 3, and then you have a 9 minus 2x. This would be 2 to the exponent 5, and that's 3 subtract x. That's the only common base of those numbers. 4 would not work. 4 does not work with 8, nor does it work with 32. So 2 is the only one that would work. All right, make them equal to each other. So 27 subtract 6x equals 15. Subtract 5x. I'm going to add 6 to the other side. That's positive 1x. I'm going to subtract 15. That's 12, and I got my answer. Number 7, common bases. So 1/5 can be written as 5 to the negative 1. And we have a u squared plus 8. 125 can be written as 5 cubed. And I have a u squared subtract 3. Now the bases are the same. Then you can take the exponents and make them equal to each other. Add 1 u squared, so you get 4. Add 9, and you get 1. Divide, and you get a quarter. And then when you take the square root, it's positive or negative, and the square root of 1 and the square root of 4 is 2, and you have your two answers. Here, make the bases the same. 1 over 27 can be written as 3 to the negative 3, and we have a c plus 4. Here, we're going to combine them together by adding. So c, and then 4 and negative 9 together is negative 5 by adding them together. Then I have negative 3c minus 12, c subtract 5. Combine like terms, add 3c, add 5, and then divide, and you get negative 7 over 4. All right, next page. Again, common bases. The common base here is going to be 3. So 3 squared and 3 to the 5. It's an A. Then once the bases are the same, then you can make the exponents equal to each other. Again, that's an A. So add 8, subtract 15, and then divide. So it's negative 15 over 18, or you could write it as negative 5 over 6. Number 10, get the bases to be the same. 16 can be written as 4 squared. 64 can be 4 cubed. And then once the bases are the same, now the exponents. Combine like terms, so I'm going to actually subtract 2m and then divide. So it's negative 2 over 11. Number 11, get the bases to be the same. So in this case it'll be 6. So 6 to the negative 3, and there's already a negative 2k. 6 to the negative 2, and there's a k plus 2. Make the exponents equal to each other. Be careful of the signs. Add 2k. Divide. And you get negative a half. Number 12, the common base will be 7. So it's 7 squared. And 7 to 3. Exponents equal to each other. It's a quadratic, so I need to make it equal to 0. So we're going to subtract 3, and we're going to subtract 5. Actually, in this case, I just need to... 3 times 5 is 15, silly. So subtract 6, and then square root, and the answer is positive and negative 3. All right, here's an example. Bases, so it's 4 squared. No, silly, not 4. 2. 2 to the 4, negative 3y. And 1 over 8 can be 2 to the negative 3. This is going to be 2 to the negative 5. And then I can just understand it's negative 12y plus negative 3, and then negative 10y plus 15. So when the bases are the same, you're just adding. So I just added the exponents and then distributed. Now I just need to combine like terms. So I'm going to add 12y, so it's 2. I'm going to subtract 15, so it's negative 18. So when I divide, the answer is negative 9. 14. Common bases would be a 5. No, 25. That's easier. So just keep 25 the same. You could use 5, but it'd make the numbers bigger. So 25 to exponent 3. 2. 25 times 25, right? 2. 25 squared. Got it. If you use 5, you get the same answer as long as you did the math right. Notice 1 is 25 to the 0. So what we have is 7p subtract 2 plus 6 subtract 4p equal to 0. Combine like terms, I have 3p and then 4, and I'm going to subtract the 4 and then divide, and you have your answer. All right, one more. 2 more. So the common base here will be 3. So 3 to the negative 4, and 3 to the 3, and 3 to the positive 4, and there's a 1/2 there. So now all the bases are the same. So we have negative 8w plus 3 is equal to 2, because half of 4 is 2. Subtract 3, and then divide. All right, one more, number 16. There it is. The common base here will be 4. So 4a squared, 4 squared, 2a, and then 4 cubed, and we have a 2 minus a. So we have a squared, we have 4a plus 6 minus 3a, because when you're multiplying, you add the exponents. So I need them to be equal to 0 because it's a quadratic, so I'm going to go 4 subtract 3 is 1, but that 1a will be subtracted. I'm going to subtract 6, 2, and then I'm going to factor. So the numbers are negative 3 and positive 2. So when I solve it, I get positive 3 and negative 2. All right, GMath out. You did your homework. Good job.